All right, so we got Unit 1, End Assessment Study Guide, Transformations. Number 1, what is the measure of angle B? So trying to figure out the degree here, or the measure. Okay. What do we know all interior angles of a triangle have to add up to? Right, so the hint there is the triangle sum theorem. Right, so what does that mean? That means that angle B, right, the measure of angle B, plus the 80 degrees, that's already given, plus the 40 degrees, right, is the measure of angle C, all have to add up to how many degrees? 180, right? So combine my terms. Let's see, B is the variable that we're solving for. 80 plus 40, 120. All right, and 180. What plus 120 gives you 180? Or if you want, you can just apply the algebra and your measure, right? So what's 180 minus the 120? And that's just 60 degrees. So angle B here has to be 60 degrees, which makes sense, right? You add up the 60 and the 40, it's 100. 100 plus that 80, 180. That checks out. Now for number 2, we really have to test each option here, and there's 6 of them, right? A through F. So we actually have to really try to validate which transformations here would take figure F onto figure or the image F prime. So let's go ahead and figure that out. Number 1, they say reflect figure F across the x-axis. Well, here's your x-axis, right? And if you reflect across, right, this point would map over here. This point would map over to this point. This point would reflect across X, map onto there. And this corner piece right here will map over there. So yeah, that reflection would work. Okay, so you would just reflect over the x-axis, and you would map perfectly onto the image F prime. So that would work. Let's see. So A would work. What about B? Reflect figure F across the y-axis. Oh, well, if we went across the x-axis, we'd be reflecting over that way. But there's no image there, right? If we reflect across the y-axis, right, all your vertices would reflect over here somewhere. That's not where we are. That's not where we're trying to map onto. So that would not work. And that's a no. So B is definitely a no-go. What about C? Rotate figure F 90 degrees clockwise around the origin. So this is the origin, right? If we reflect at 90 degrees, this point would become that point. And would that work? That point works. What about the other points? What about this point in reference to this point? Would those be 90 degrees also? Looks like it, right? So this point reflects across or rotates 90 degrees over there. This point rotates all the way over to here. You can test the other 2 points, and I would say yes, that would work. That would work. You can always test the idea too by drawing the lines between the perspective or corresponding points. You can always go point by point. That way you can see it for yourself. And if you notice, each point looks like it goes by a 90-degree clockwise, right? So yeah, that would work. Let's clean this mess up a bit. All right, option D. What do we have? Rotate figure F 180 degrees counterclockwise. So the reverse of a clock. Well, if we do that, and we're rotating around the origin again, which is right here, right, 0, 0. If we rotate 180, here's 90, right? You would land over here, right? And then another 90, which is 180, right? Two 90s is 180. We're going counterclockwise, so reverse of a clock. You would land here for option D. Not there. So no, that transformation would not map onto what we want to map onto. All right, option E, translate figure F so that 4, 1, so they're giving us a point here, goes to 4, -1. Let's test that theory. We have 4, 1 right here, right? And they say to go to 4, -1. So that means this image, or this figure, F, moves down until this point maps onto that point. Okay, and that means this point right here would have to map on to that point right down there. And the other 2 points would also go down 2. Same amount. And that's where we would land. Does that work? No, not far enough. So no easy translation for us on that one. All right, so let's see. Option F says translate figure F so that 1, 4 goes to 1, -1. All right, so very similar to option E. This time they're giving us a different direction with a different magnitude, it looks like. It looks like I'm going a little happy with my eraser here. There we go. So we got 1, 4, which is right there on the top left of figure F. And then it goes down all the way to 1, -1, which is also the top left of the image, right? So every figure has to go down. How many did we go down? We just went straight down, right? 1, 2, 3, 4, 5. We went down 5 places. That means all the other points need to go down 5 places. So 1, 2, 3, 4, 5. That corner would work. Let's try this corner right here. 1, 2, 3, 4, 5. That would work. This one over here. 1, 2, 3, 4, 5. Yes. So figure F would map onto the image F prime if we were to go down on a translation with those 5 units. So notice how I had to test each one to kind of validate them or not. All right, number 3. So select all transformations that take rectangle ABCD onto itself, right? Just like a skateboarder trying to land after they do a kickflip. Skateboard needs to map onto its original placement, otherwise somebody's going to get hurt. So let's see. Part A, rotate, so we have to figure out, again, all transformations. So I have to validate each one. Rotate 90 degrees clockwise using center P. Well, that's no good, because if we just rotate 90 degrees, right, your board is going to land this way, right? And it says rotate clockwise. So that means A is going to be here, B is going to be there, or I'm sorry, other way around. Went a little too fast on that one. B is going to be over here, A is going to be here, and D and C. The skateboarder is not going to have a good time if he lands that way. So no, rotation 90 degrees is not good enough. Now part B. Part B says rotate 180 degrees. Aha. And it says clockwise using center P. Well, remember rectangles here. Okay. If you rotate 180 degrees, that means point A is going to rotate all the way around 180 degrees, map onto here, right? Which will be on C. B is going to rotate 180 degrees, and it'll map onto where D was. And C is going to do the same thing. It'll rotate over here. And it looks like I went the wrong way, didn't I? Clockwise. I was going counterclockwise. If you notice that, give yourself a pat on the back, because you earned it. Clockwise. So let me make sure I do that properly, just out of pure paranoia. It's the funny thing about trying to see transformations. All right, so clockwise. So A is going to go this way, 180 degrees around P, land onto there. B will also rotate 180 degrees, land there. And then D is also going to rotate counterclockwise and land right here. And I think I already did C. C is going to rotate and land where A originally was. So yes, all those points, your rectangle will map onto itself. Okay, that's why in like the X Games, when you have the skateboarders, right, it's like they do a 180, a 360, right? But every 180 they do, the skateboarder should land just fine, right? The wheels will be going the right way for the landing. So yes, B would work. Now a reflection across line M, right? Line M is going across here on this dotted line. That means A reflects over here, same distance, right? Across to D, that works. B will reflect also across, map onto C. D will reflect across line M and land on A, as will C reflect across and land on point B. And just for you artists out there, do you see the cylinder? Right? So a cylinder is really just a rectangle just spinning around super fast, yeah? Nice. Three-dimensional figure being created right there. That's pretty nifty. So yes, a reflection would work. Cross line M. All right. Reflect across diagonal AC. Whoa. Here's AC. If we reflect across, right, B would be over here, like it'll reflect over here somewhere. D would reflect across over here, somewhere there. There we go. A would stay the same. C would stay the same. D would be over here though. So your image would actually look like then something off, something like that, it wouldn't map on. It'd be very off tilt. Okay, so no. E says translate. All right, by the directed line segment from A to B. Well, that's weird because if we do that, we don't map on the original figure to its image. We just move it over, right? We just translate over. So you're not going to be mapping onto the original figure. What I mean by that is if we go by the directed line segment from A to B, right, from here to here, A will be here, right? B is going to also slide over, right, to over here. D is going to move over to where C was. And C is also going to go by that directed line, be over here. So your rectangle now slides further over than what you wanted. And that does not map on to the original figure. So no, that does not work. All right, number 4. Is there a rigid transformation that takes rhombus P to Q? Rigid, right? So distance and angles must be preserved. The measures might be, right? This looks to be congruent to that. So all your sides are congruent to one another. That's fine. What about the angles though? Right? These angles don't look the same. Right? So the angles are not preserved. So no, not rigid. Right? The angles are not preserved. Now, in simple terms, it's like, you had this really messed up box that somebody sat on, and then you try to fix it. It looks a little bit better, but your friend's still saying, like, what happened? Like, why is it all rhombus-like? It's like, oh, somebody sat on it and I tried to fix it. It's like, we already know something happened to that box. All right, number 5. What are the angles of rotation? So, again, this is for number 5. What are the angles of rotation? So this is a pentagon, yeah? We have how many sides? 1, 2, 3, 4, 5. Great. Now, the real interesting thing here is, remember, we have out of 360 degrees for full rotations. Well, you have 5 sides. So what is 360 degrees divided by 5? It's the easiest way to find your angles of rotation for this regular pentagon. So 36 divided by 5, what do you get? Right, you say 7 and then carry the 2, or I'm sorry, 1, remainder 1, 0, 2. So 72 degrees, that will work. What if you rotate another 72 degrees? What's 72 times 2? 144, right? What about another 72? 216? So every 72 degrees that you rotate, the pentagon will map on to its original self. All right, number 6, draw an image of a quadrilateral ABCD after a translation that takes A to A prime. So A is going to translate over here. And how many places does that go? 1, 2, 3, 4, 5. So we're doing translation of 5 units to the left. Well, that means every other point needs to go 5 units to the left. So we'll start with D. 1, 2, 3, 4, 5. So D prime will have to be here. C will also have to go over 5. 1, 2, 3, 4, 5. It'll land right there. B also has to go 5 to the left. 1, 2, 3, 4, 5. Right. So your new image will exist right here. And that's a nice translation from A to A prime. So again, every single point also needs to move and undergo the same distance, the same direction heading, the same translation. Okay. All right, part B, they say draw the image of quadrilateral ABCD after a rotation 90 degrees clockwise, all right, around the origin. Again, the origin is right here. They say clockwise, so 90 degrees. So A is going to rotate 90 degrees. That's 90, so A prime will be here. We have, right, from here, from our center of rotation to B, 90 degrees. Let me draw this correctly. There we go. So B prime will be right here. We have D as well. So let me draw this line. There we go. And D is going to be over here, and C prime is going to be over here. Trying to draw it as finely as I can with such a sensitive pen. All right, so let me explain what I did. Okay, I just used 2 points to kind of get an idea. And then what I noticed was this rotation is a rigid transformation. That means from A to D, right, I noticed it's up 3 and over 1. But if I rotate, it's going to be to the right 3, down 1. Right? And then C is just going to be, instead of 2 to the right, it's just going to be 2 below D prime. So that's how I was able to finish the rest. You could do the 90 degrees from the center of rotation as well. It's another way you could do it. But if you remember that rigid transformations preserve distance, then you will be able to map your image to where it belongs. All right, number 7. So with number 7, let's see here. For number 7, you have these 2 lines, EG and FH, and they tell you they're parallel. Wonderful. That means they never cross one another. Okay? They never have an intersection with one another, except for this transversal. Right? The transversal, we can call it line AD if you want, which does cut through, right, both those parallel lines. Now it says name all angles congruent to angle ABE. Angle ABE is right here. Okay, we do know about vertical angles, so this angle has to be congruent. Right. We also know that angle BCF also has to be congruent, and BCF has a vertical angle, angle DCH, right, which also has to be congruent. So those 4 angles right there would all be congruent to one another. So you have angle, again, let's say CBG. You have angle BCF. And you also have angle DCH. All right, so those are all congruent to angle ABE. Now the reason that angle ABE, is congruent to angle BCF is because they're parallel. That means they have to cut that transversal at the same angle in order to be parallel. Okay. Now they say in part B, write an equation that represents the relationship between angle FCD and angle HCD. So let me use blue here. Angle FCD, which is this angle right here, and angle HCD. HCD is the red one right below it, this one right here. Now, do you agree that they both share this line? And lines are 180 degrees, correct? For their angle measurement. So we do know that angle FCD, whatever measure that is, if added with angle H, or the measure of angle HCD, they both have to add up, right? Their sum has to be 180, because with them together, they will land flush with line HF. All right, number 8. Again, triangle sum theorem comes up, right? We know that triangles have to add up to 180 degrees. We can use that to find this missing angle right here first, right? So you have 86 degrees plus the 63 degrees plus, I'll call this y degrees, right? And it has to add up to 180 degrees. All right, so this is a two-step problem. So let's combine like terms. What do you get? Get 6 plus 3, that's 9. 8 plus 6, 14. 149 degrees plus y, right, is 180 degrees. Subtraction property, right? And y equals, what, 31 degrees? So if y is 31 degrees, and if you add x and y together, right, they should give you 180 degrees. Very much how in the last problem we had that situation, right? So 31 degrees was for y. What's the missing piece? What do you get? 149. So that is how you find the missing angle. Okay. Question. What do you notice? What do you notice? Could there have been a faster way to do this? You could have just combined these two angles, gotten your answer right away. Fascinating, right? So just be aware of that. It's a good thing to be aware of. All right, number 9, describe a sequence of rigid transformations that takes triangle ABC to DJI. Well, first things first, I notice right away they're not oriented to one another at all. So I'm going to go ahead and rotate. So first things first, going to rotate triangle ABC counterclockwise with the angle of ABC. That's the angle symbol. So notice it looks like a 90 degree. So I'm going to rotate, again, counterclockwise. If I do that, let me undo that. That's horrible. It's not a straight line. Trying to go as best as I can here. So C is going to rotate, and it's going to go up here. A is going to up on somewhere around there. So notice how I rotate first, and the reason is I need to get these triangles to map onto one another, and I'm going to go ahead and rotate first so I can set up a translation and then a reflection. So a translation is the next one. I have to move this triangle right down here. So I need to move to where C can map onto I and B can map onto J, and then A is coming down for the ride. All right, so A is right here. So that was a translation, right? So step 2, translate triangle ABC along, we can say B to J. Okay. Last but not least, we can reflect triangle ABC across line IJ or JI. Okay, if you do that, A would reflect across and map onto D, C will stay where it is, B will stay where it is, they just magically become I and J, right, because they map on perfectly right here. So first things first, I rotated, right, along angle ABC, and that was counterclockwise. Then I did a translation, right, along from B to J, and then lastly, a reflection across IJ. Okay, so those were the 3 steps I took for my sequence so that I can map triangle ABC onto triangle DJI. All right, this one is very similar. Definitely looks like you need to do a rotation, a translation. So I don't want to give this one away. I will tell you it's hauntingly similar to this sequence here. So I'll tell you what, this one's for you. I know it was in the assessments assignment from last week. If you do it correctly, email me, let me know, and I will give you extra credit. Okay? It's a good one, so I don't want to steal that one from you. All right, good luck, study. If you have any questions, let me know.